Right, let's look at the next one. So we've got fx equals 2x cubed minus 7x squared minus 17x plus 10. Use the factor theorem and division to factorise f of x completely. Total for question 1 is 6 marks. So 6 marks tells you straight away there's going to be a bit of work involved here. So in the questions where they don't give you a factor, you have to put in some numbers yourself just to see which ones are actually factors. So in this case, what you typically do is you just start at the beginning. You go through 1, negative 1, 2, negative 2, and see if it turns out that f of whatever number you substitute in here equals to 0, therefore it's a factor. So let's try some. So this is where the calculator comes in handy, it's quicker. So what you're going to do is we'll just start, you do 1, what I typically do is 1, then negative 1, 2, negative 2, and it's typically, I very much doubt it's going to be beyond 3, okay, because they know it's an exam, you've not got that much time. So f of 1, you don't have to write this out every single time, I'll just do it this one time, the rest you can do in the calculator. So all I've done is just taken 1 because it says use the factor theorem and division to factorise f of x completely, but they've given us no factors, so we don't know what are factors and which aren't. So start with number 1. So what you're going to do is 2 times 1 cubed minus 7 times 1 squared minus 17 times 1 plus 10, which gives us minus 12. Therefore, not a factor. Okay, you don't have to write that in every time, just showing you this time. So what we're going to do now, for quickness, we're just going to use the calculator to see which ones work, which ones don't. Okay, so if I was to do f of minus 1, I think it's helpful just to leave that on the calculator. Just leave what you've put in. So all you're going to do is substitute in the factor each time. So this time we're just going to replace that with a minus 1. Yeah? Saving you having to type the whole thing out every time. So minus 1 and then times 17 times minus 1 plus 10. So that gives us 18. It's not a factor. What about f of 2? So again, all I'm going to do is just substitute the x for 2 minus 36. F of minus 2, what's that? Is 0. That's your factor. So the question is, use the factor theorem and division to factorise f of x completely. So if f of negative 2 equals 0, that means negative 2 is a factor. We can factorise f of x completely. So this just takes 2 seconds. You could do this. What you do is you take the coefficients and put them along the top here. So we've got 2 minus 7, remember it's descending order, minus 17 and 10. Okay, we know minus 2 is a factor, so put that outside. And from here it's fairly straightforward, so remember the rule, the first one comes down just to make 2, and then you multiply each time you bring the term down and you add it consecutively. I'll show you. So bring 2 down. 2 plus 0 is just 2. Negative 2 times 2 would be minus 4. What's negative 7 minus 4? That's minus 11. Minus 2 times minus 11, that's positive 22. What's minus 17 add 22? That would be 5. Minus 2 times 5 would be minus 10. 10 plus negative 10 would be 0. So how do we write that? If negative 2 is a factor, how does that appear in the bracket? That's written like that. Yeah? Because if, for example, if we were to make that equal to 0, 2 would be taken to the other side. X equals minus 2. Okay? So as a factor, it's written like that. And then we use the remaining coefficients here, but we've gone down a power. We started off at cubed, we're now going to be with squared. So it's 2x squared minus 11x plus 5. But the question asked us to factorise f of x completely. So we can keep going here. So that stays the same, can't do much else there. Okay, so let's factorise this part over here. This can go a bit further. So we can see what the factors of 2 and the factors of 5 that would give us negative 11. This one isn't too complicated, so we're going to have 2x and x here. Just think of FOIL, 2x times x would be 2x squared. What are the factors of 5? It's going to be 5 and 1. Make sure you get them the right way around. Even though the factors have to be 5 and 1, 5 doesn't go there, okay? Make sure you double check it using FOIL, okay? Because it's going to give you the wrong answer otherwise. If this was a 1 here, you'd have 2x plus 5x, which is 7x, or depending on the signs. You wouldn't get to 11x though, okay? So be careful. It's positive, and this is negative, so that tells you that both signs are going to be the same, and this tells you which sign it's going to be, okay? Double check it using FOIL. First, outside, inside, last. So you got 2x times x is 2x squared, minus 10x minus 1x is minus 11x. Negative 1 times negative 5 is positive 5. And that's your answer. Right, next one. So g of x equals 4x cubed minus 8x squared minus 35x plus 75. Part A. Use the factor theorem to show that x plus 3 is a factor of g of x. Okay, so they've given us a factor this time, we just have to prove it. Okay, so remember, if x plus 3 is the factor, we have to make this equal to 0. And from there we can see that if it's a factor, x would be equal to negative 3, okay? Not positive 3. X plus 3 is a factor, therefore x equals negative 3, okay? So to prove it's a factor, I'm just going to substitute it in here, replacing all the x's with negative 3. So it's going to be, I'll put this in the calculator, but just to show you exactly what I'm doing, this is what I'll be putting in the calculator. 4 times negative 3 cubed minus 8 times negative 3 squared minus 35 times negative 3 plus 75. And if I put that into the calculator, it should be equals 0. Okay, so that's part A. Part B. Hence, show that g of x can be written in the form gx equals x plus 3 bracket x plus b all squared, where a and b are constants to be found. Okay, so we know that x plus 3 is a factor, so using synthetic division, like we did in the last question, we can fully factorize. Okay, so again, let's set up. We know negative 3 is a factor, and then we put the coefficients along the top again. Okay, so we've got 4, negative 8, negative 35, and 75. And we're hoping for 0 here. So again, you bring the first term down. Negative 3 times 4 would be minus 12. Minus 8 minus 12 would be minus 20. Minus 3 times minus 20 would be positive 60. Minus 35 plus 60 would be 25. Minus 3 times 25 would be negative 75. And as you can see, 75 minus 75 is just 0. Okay, so we've got x minus 3 is a factor, we already knew that. And then what have we got here? 4x squared minus 20 plus 25. So the question is, hence, show that g of x can be written in the form g of x equals x plus 3 bracket ax plus b all squared. So we have the x plus, oh, beg your pardon, that should be x plus 3. Yep, so, yep, common mistake. X equals minus 3, but x plus 3 is the factor, as I did over here. I should practice what I preach. X plus 3 equals 0. X plus 3 is the factor, but x equals minus 3. Remember that, you have to set it equal to 0. Okay? Very common mistake, as I've just shown. But this part can still be factorised. X plus 3 we can't take any further, but we can factorise this. Okay? So we can see 2x and 2x. And remember, this sign tells you that whatever this sign is, they're going to be the same. That's what that means. It's positive. So whatever this sign is, they're going to be the same. So in this case, it's negative and negative. And we can see it's a square number as well. Okay, so we're going to have 5 and 5. And because these are both the same, this can be rewritten as x plus 3, 2x minus 5, all squared. And the question said, hence show that g of x can be written in the form g of x equals x plus 3, which we have, times ax plus b all squared, where a and b are constants to be found. So you could leave it like that, But just to be on the safe side, I'll probably label what a and b are. So a, in this case, is 2, and b equals -5. And that's your final answer. Okay, let's try the next one. Okay, f of x equals x cubed plus 6x squared plus px plus q. Given that f of 4 equals 0 and f of -5 equals 36, part A, find the values of p and q. So we know that f of 4 equals 0, so let's substitute that in. We know that. No, that's going to be a factor, but we've got unknown variables here, p and q, 2 unknown variables, so you can almost guarantee once I've substituted in 4 and then I've substituted in -5, we're going to have to use simultaneous equations. So f of 4, so it's going to be 4 cubed plus 6 times 4 squared plus 4p plus q. Okay, so you might not need the calculator for this, but I would just get in the habit of using it anyway. You'll have your calculator with you just to avoid any human error. I would just double check. So you get 4 cubed plus 6 times 4 squared, so you get 160 plus 4p plus q. Okay, the next bit's slightly different because even though we're going to substitute in a value for x again, f of -5 this time, it's not going to be equal to 0. Okay, so everything else is the same. 6 times -5 squared plus -5p plus q equals, as the question says, 36. But everything else is the same, so if we put that in the calculator, -5 cubed plus 6 times -5 squared will give us 25. So we've got 25 on the left hand side, so 25 minus 5p plus q equals 36. So I take the 36 over here just to have everything on the same side. 25 minus 36 is going to be minus 11 minus 5p plus q equals 0. Okay, so now hopefully you can see that we're going to use these two equations here, okay, to solve the two missing variables p and q. I should have put in here that that's equal to 0. They told us that at the start. Therefore 160 plus 4p plus q equals 0. -11 minus 5p plus q equals 0. Okay, we're going to equate these. So hopefully you remember how to do this. We're trying to cancel, and we can see here that we've got 1q here and 1q here. So if I subtract, we've got what? 160 minus -11 is the same as 160 plus 11. So that's 171. 4p minus -5p is the same as 4p plus 5p. So that's plus 9p. Q minus q we just cancel, so it equals 0. Therefore, 9p, if I take the 171 to the right hand side, is -171, and on the calculator you will see -171 divided by 9 is minus 19. Okay, and you should know that once you've found one of the unknown variables, in this case we found p first, we can just sub this back into either equation, doesn't really matter which one, and we'll find q. I'll just use this one, we've got smaller values to deal with, so we'll say -11 minus 5, substitute in the -19, plus q equals 0. And again, like I said, it doesn't matter which one you use. We'll call that 1, we'll call that 2, the first equation or the second. It doesn't matter. You've equated them to each other, so it doesn't matter which one you put it into. You're going to get the same answer. -11 minus 5 times minus 19 equals 84. So we've got 84 plus q equals 0. Therefore, doing the opposite, take 84 over there, we've got -84. Okay, so that was only 3 marks actually for part A, which seems a bit harsh. There's quite a lot going on there, but you need to find these values before you can do part B. Okay, so part B says factorise f of x completely. So this is where we substitute in the values for p and q that we've just found. Therefore, f of x equals x cubed plus 6x squared minus 19x minus 84. Okay, and going back to what it says at the start, given that f of 4 equals 0 and f of negative 5 equals 36, that means f of 4 is a factor. F of negative 5 is not a factor because it doesn't equal 0, but because f of 4 does equal 0, it tells us, therefore it's a factor. So therefore we can go straight into synthetic division. If f of 4 equals 0, we can put the 4 on the outside, and we can put 1, remember the coefficients. So we've got 1, we've got 6, minus 19, and minus 84. Okay, we're hoping to get 0 here. 1 comes down, there's nothing to add it to, so 1 plus 0 is just 1. 4 times 1 is 4. 6 plus 4 would be 10. 4 times 10 is 40. 40 minus 19 would be 21. 4 times 21 would be 84. And then negative 84 plus 84 is obviously 0. So again, like the last question, we can write it as x minus 4. We're factorising, so we were at x cubed, but we're factorising, we're taking a factor out, so we've gone down in value. So we're now going to be looking at a squared value. So we've got x squared plus 10x plus 21. So we've got x minus 4, can't do much more with that, but we can factorise this one. So x squared would obviously have to be x and x. What are the factors of 21 that would give you 10? It's going to be 7 and 3. Doesn't matter which way you put them this time because it says that the signs are the same and they're both positive, so you're going to add them together anyway. So final answer would be x minus 4, x plus 3 and x plus 7. And that was 7 marks for that question, so quite a lot going on, but like most of them, just one bit at a time. And there's no real individual part that's difficult. It's just making sure you don't make any silly mistakes. Okay? Right. Let's do the next one. So we've got f of x equals x cubed plus 6x squared plus 4x minus 15. Part A. Use the factor theorem to show that x equals negative 3 is a solution to f of x equals 0. So yeah, this part A is fairly straightforward. You know what's going to happen here. Just going to put f of negative 3 equals negative 3 cubed plus 6 times negative 3 squared. Just a straightforward substitution. Plus 4 times negative 3 minus 15. So if I put this into the calculator, so negative 3 cubed plus 6 times negative 3 squared plus 4 times negative 3 minus 15 on the calculator gives 0. Good. Okay, so it's 2 marks for that. Fairly generous because most of that you can just do in the calculator. But yeah, it's just proof that f of negative 3 is 0. Okay, part B. Find the other solutions to the equation f of x equals 0, giving your answers to 2 decimal places. Okay, so straight away when you see that, giving your answers to 2 decimal places, we can't solve this just by factorising normally. We're going to have to use the quadratic formula. Okay, but we're not there yet. We can start off by doing synthetic division again. We know that x equals negative 3 is a solution, so like last time, let's put that in. So we've got negative 3 is a factor. Again, put the coefficients in. What numbers are in front of the x? So we've got 1, 6, 4, and then the last one is minus 15. And we're hoping for 0. So again, as before, this comes down 1. There's no value here. 1 plus 0 is just 1. Negative 3 times 1 would be negative 3. 6 plus minus 3 is the same as 6 minus 3, which is just 3. Negative 3 times 3 would be negative 9. 4 plus minus 9 would be minus 5. Negative 3 times negative 5 would be positive 15. You don't have to put the positive in, but just to highlight the fact that it's the opposite to negative. Negative 15 plus 15 is obviously 0. Okay, so therefore we have this equals x plus 3, and we've got x squared plus 3x minus 5. Okay, so they've already told us in the question that they want the answer to 2 decimal places, or the answers, plural, to 2 decimal places. A couple of ways of doing this. You could do the quadratic formula, you could write it out, and then you could put the fraction into the calculator. You could do it that way, and you would get your 2 decimal places, or you could just put it straight into the calculator. So shift, press the log button, You've got number 1 simultaneous equation, or number 2 polynomial. Click number 2. Polynomial degree, we've got squared, so we're going to put squared here. We've got 1x squared 3x minus 5 equals, okay? It gives us, so if we were to do the quadratic formula, if you were to write it out properly, these are the two solutions you would get, okay? Minus 3 plus root 29 over 2, and minus 3 minus root 29 over 2. Okay, so on the class whiz, rather than leaving it as negative 3 plus root 29 over 2, you press this button here, which is converting it from standard to decimal, and that gives you the first answer, first solution, which is 1.19 to 2 decimal places. The next solution, negative 3 minus root 29 over 2, convert from standard to decimal, negative 4.19. Okay, so therefore, your final answers are x equals 1.19 and negative 4.19. Okay, so 7 marks for that question, but I think maybe half of it is on the calculator. But yeah, 7 marks. And that's it. For maths tuition, in person or online, you can visit the website at analogos.co.uk. The link is in the description.